So you have, up to this point, solved problems like this. If I said sine of x is equal to, I don't know, a third. It's like a grade 10 problem. And I would say, what is the angle? What is angle x? It gives you 1/3. You would have gone, well, what would you have done? What button would you have hit on your calculator? Oh. How do you solve for x here? Yeah, it's the sine. Remember this thing? That is the inverse sine, the actual inverse function. It's called the arc sine. We just say sine of -1. All right, and then that would spit out an answer. And I'm going to sneeze. I don't know what the answer is. They may know what the answer is. Sine of a third. 19.47. All right, sounds good to me. So you get 19.47, and I would mark it right on your test when you were in grade 10, and everybody would be happy. It's only half the answer, not the full answer. Because if you think about it, you don't have to write this down. That's 19.47, right? I can draw a reference angle over here that is 19.47. I should have picked a better number here. If that's 19.47, what is the rotation angle to get there? It's getting really blurry right now. It'd be 180 minus 19.47, so it'd be 161 point whatever, 53. I'm good at math. Is that right? 169.53? That would be my rotation angle. So if you do sine of 169.53, what do you get in your calculator? Or 161? Damn it. 160.53. Good thing I'm recording all this. So sine of 160.53, you should get 0.3 repeating or something close. Yes. So you get two answers. There's actually two possible answers here. All right, and it's because of the reference angle and the fact that sine is positive in these two quadrants. All right, so now when we solve questions like this, we can have two answers, we can have three answers, we could have four answers, we could have no answers. And starting tomorrow or next week, we could have an infinite amount of answers. Doesn't that make you feel good? So for right now, there's only going to be two for the first couple of examples, actually, for this example. Next one has four. But here we go. Cos theta is equal to negative 0.5. The first thing you do is you look at this negative sign and you go, where is cosine negative? Which quadrant? Two and three. Boom, boom. So I know I'm there. Okay. I need to find the reference angle. So I need to know what those two angles are. To find the reference angle, so first of all, we're in quadrants 2 and 3. The reference angle, which I will abbreviate REF, angle sine, is the inverse, so cos to the -1 in this case, of the positive value. Don't use the negative. The negative only tells you the quadrants you're in. You will get, well, you only get half the answer if you use the negative, okay? So don't use the negative. So cos of 0.5, the inverse cos of 0.5, what is that? Please practice this on your calculators because you're going to have to do it. 60 degrees. So I know that this is 60 and that is 60. So now when I say what is theta, basically I'm saying what rotation have I done from the origin to get to the first line? How far have I rotated? What angle? 120 degrees, right? 180 minus 60. If I keep going to get to there, how far have I gone? 240 degrees. And if you punch those into your calculator, if you go cos of 120 and cos of 240, you'll get negative 0.5. Okay? Is that okay? We're going to do another example. But what would you like me to repeat? Okay, we're going to do that in the next one, okay? Because you do it in every question. So it's a good question. All right. So let's look at this next one here. Given that sines theta squared, so this is just a notation that they're saying at the beginning. When you want to write sine theta all squared, this is the notation they use, sine to the power of 2 theta, okay? So if I want to solve this, I'm actually solving this. How do you get rid of the square? I don't want sine squared, I just want sine. You square root both sides. When you square root both sides, what do you need to remember? Plus or minus. Somebody please tell me what the square root of 0.5 is as a decimal. Like that. Close enough. All right, 0.707, okay? Now, it's positive and negative. If it's positive and negative, where is sign positive and negative? What quadrants are we talking about? Well, okay. Where is sign positive? First, second. Where is sign negative? Third and fourth. So if I say its sign is positive and negative, we're in all the quadrants. So we're going to have 4 answers for this one. All right. So I need to know the reference angle, which is these angles here. To find my reference angle, you do the inverse. So sine to the -1 of the positive number. Do not do the negative number. And if you do that, you should get, anybody want to tell me? Rounding to the nearest degree. 45 degrees. So that's 45, that's 45, 45, and 45. So now I want the rotation angle, which is essentially start here. What angle to get there? 45, that was pretty obvious. What angle to get to there? 135. And then to the next one, 225, and finally 315. Okay, so you've got 4 answers now for that one. Right? When you square root something, you're going to get all 4, basically. Is that okay? Yep. Let's try it. What's if you do the negative, what do you get? Negative 45? Is that what it is? Okay, so in this case, it actually gives you the reference angle, which is, I guess that makes sense because it's this angle here. So negative 45. Some cases it'll spit out like 120, which is actually one of the answers, but it doesn't give you the reference angle, so you'd still have to find it. Okay, so in this case, it still gives you a version of the reference angle, but reference angles can't be negative. So, all right. Next page. Let's do, yeah. do one more. Solve cotan x is equal to root 3. This is a domain restriction between 0 and 360, so we're only talking about one circle. All right, what is cotan? 1 over what? It's 1 over tan. We don't have a cotan, so we're just going to rewrite this as 1 over tan of x is equal to root 3. I want to get the tan out of the denominator, so I'm going to multiply it up to the other side. So you get 1 over root 3 is equal to tan of x. You don't have to show this step if you remember that cotan is 1 over tan, so I just flip that, and you could just go straight to that. Tan is equal to 1 over root 3. Okay? All right, it's positive. Where is tangent positive? What quadrants? 1 and 3, right? Add sugar 2. Okay, I need to find the reference angle. How do we find the reference angle? What is it? Oh, it's 1 over root 3. It's 30 degrees, right? Okay. So that's 30. That's 30. So what does x equal? My rotation angle. Yeah, is the first one is 30. And then to keep going all the way to there is 210 degrees. All right, let's do one more. Let's do this one, B, at the bottom of the page. Cosecant theta is undefined. What's cosecant? One over sine. I'm saying it's undefined. How do you get undefined in math for what we've done? You divide it by 0. So what that means is you're dividing by 0. Okay. So what are we trying to find? What does sine have to equal? We're trying to make sine equal 0. Because if you manipulated this and you multiply the 0 up and the sine up there, you're going to get 0 is equal to sine. Okay? Is that okay? I just multiplied 0 up, 0 times anything, gone. Sine times, that's some constant. I don't actually care what it is. So sine is equal to 0. What is my reference angle? Zero. Okay. So if you're on your grid system, and I said the reference angle is 0, where are you? You're there. Where else? 180. There. And if you keep going all the way around, you'd be at 360 as well, right? So what is this, theta? Yeah. What does theta equal? It equals 0, 180, and 360. All right? Use the sign to determine what quadrant you're in, find the reference angle, mark it in, figure out what your rotation angle is. Any questions? All right, I would like you to do numero, one sec, sorry. Number 1, pick 2. Number 2, pick 2. Number 3, pick 1. And that'll be it. So 1 to 3, pick 2, pick 2, pick 1. Oh, yeah, I won. I always win. Exactly, I still won. I didn't, it was planned. It was planned. All right, let's go to page 536, please. We're gonna do these 3 questions. So, determine the exact value, blah, 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 of the rotation angle. Okay. Domain restriction is in what? It's not in degrees anymore. All the other ones said 0 to 360 or whatever, right? This is in rads. So that means our final answer has to be in rads. It does not mean we have to do the whole question in rads. We can do it all in degrees and at the end convert to rads. So if we do, let's do the first one here. Sine theta is equal to a half. Where is sine positive? What quadrants? 1 and 2. What is my reference angle here? Is 30 degrees. So that means that is 30 and that is 30. So that means theta is what and what? In degrees, just tell me in degrees. And 150 degrees. Okay. If our domain was 0 to 360, that would be the answer. However, our domain is 0 to 2 pi, which is yelling at you to do it in rads. So just convert your answers to rads. What's 30 degrees in rads? Pi over 6. What's 150 in rads? So, in other words, how many 30-degree angles are there in 150 degrees? 5. So it's 5 pi over 6. And you're done. All right. There's another one I wanted to do. Is that okay? All right, let's do one more. Yeah, let's do this cosecant. No. Which one? Let's do secant is equal to negative root 2. Okay. Secant. What is secant? 1 over what? Cosine. So that means that this is cosine is equal to negative 1 over root 2, right? We can just flip that. Where's cosine negative? Two and 3. Your reference angle. Anybody tell me the reference angle? Close to the minus 1 of 1 over root 2 is 45. So we have 45 and 45. So never, never, never. So what is my rotation angle? I.e., how far have I rotated to go from here to 1 and 225? Okay, we have to be in rads. So the question is, how many 45-degree angles are there to get to the first one? 3, right? 3 times 45 is 135. And if you can look at it visually as there's 145, 2 45s, and then 3 45s to get there. So it's 3 pi over 4, because pi over 4 is 45 degrees. How many more 45s did I go to get to the next, to 225? What times 45 is 225? It's 5. So then it's 5 pi over 4. Is that okay? All right. Also, watch for ones that have domain restrictions. They might say, like, say if I was doing this one here, but I said the domain was between pi and 2 pi, i.e. 180 to 360. I would exclude that one, right? Because it's not in my domain. You can only have, so just watch the domain restrictions. If it's in rads, it wants the answer in rads. You can do the whole thing in degrees, convert to rads at the end, and just watch the domain restriction in case they limit it. I would like you to do number 4 and 6A, please. Yes, please. That's it.